Okay, now we're going to take a look at a question from A2 paper 3, which is physics 6 from June 2008. And this again is a particle physics topic. When an electron and positron meet, two photons are produced. State the name of this interaction between the electron and the positron. Well, this is an annihilation reaction. Okay, so what happens is annihilation. Okay, so we get annihilation at that particular point. Positron meets an electron, they annihilate each other, and they produce two photons. Okay, and those photons, remember, would be gamma photons. Okay? So we produce gamma photons as a result of that annihilation reaction, and that's because we have a particle meeting its antiparticle. Why is that type of interaction very rare? Well, because there's a very small number of positrons. Being an antiparticle, they don't tend to exist too long because they will be involved in those annihilations. So there's very small numbers of positrons, and that's why we don't see that interaction too much. Alright. Next part of this question asks us then to describe the principle of operation of a linear accelerator, and we should use a sketch to help explain the answer. So I'm going to try and draw a quick sketch of the linear accelerator. Now, the essential features of the linear accelerator are that we have accelerating gaps between tubes, okay, which are the electrodes, and those tubes are getting longer. So what we have essentially is we have the first accelerating gap between and these tubes are getting longer as we go along, and they should all be along the same axis. Probably it would be better to, oops, I should have made that one a little bit longer. Probably would be better to have that in a lot drawn using a ruler so that you can see that. But then what we have is we have an alternating supply, and at some point along here we have to have there's where the ion is produced. So we now have an alternating supply which is connected alternately, and that would go on, and then this one and this one are connected, and that would continue on here, and this then will be connected back to this side, and this would be connected to this side, and that's our alternating, and that would be it's a high frequency AC supply that we have there, a high frequency AC supply. And then what happens is the electrons follow along here, and we need to have some sort of ion source here. So this is the electron source, an electron source or electron gun at that point. So we have an electron gun which produces the electrons which go along. So we need to have that, and really we should have the source plus the tubes plus the fact that it's a straight path going from there and connected to an alternating current. That's what we're really looking for. Okay, then in terms of description of that, what we then have is that the particles are accelerated across the gaps. By the potential difference, so they're accelerated across the gap by the PD. The gaps are very short, so a very high field strength. The particles then travel at a steady speed or a constant speed inside the tubes. And each tube repels the particle once it's passed through it. Okay. And then the tube sections increase in length, and they increase in length in order for the time that it takes to pass through them to be constant. Okay? So the tube sections increase in length so that the particles increase in length so that the particles are inside the tube for a full half cycle. Right, so if we go back up to our diagram, then these are so these are the tubes, okay, and then this here in between, that's the accelerating gap. That's the electron or the particle source at this point here. They produce that and are accelerated towards this. Once it gets to there and travels inside, it's no longer affected by the field. It then moves to the end of this, and by the time it gets to here, this one will now have become positive or negative to attract it across the gap. It then accelerates across the gap and travels through here. It takes the same time to go through here as it does to go through here. So it takes the same time through the first tube, through the second tube, the third tube, the fourth tube. It takes the same time all the time. And so by the time it gets through, this has been synchronized so that it is always accelerated across the gap. And that's the answer to that question complete.